Good evening, friends. It's our pleasure that we have been joined by the expert speaker for the second session on this sixth day of the Faculty Development Program on Emerging Tools and Trends in Contemporary Research. It's my pleasure to welcome one of my close friends and associates, Dr. Soumen Shah, sir. Dr. Soumen, you can on your camera for a second, sir. Dr. Soumen, are you able to listen to me? Dr. Soumen.
Yeah. Hello.
Hello. Yes, Dr. Soumen, are you able to listen to me?
Hello.
I am getting your voice. Are you getting my voice, Soumen?
Yeah, I am getting.
Okay. Your camera is off. Some bandwidth problem from your side, Soumen.
Visible and audible?
No, you're not visible. You are audible but not visible. There is some bandwidth. Yeah, now you are visible. Sitting on beach.
Is it okay now? Hello?
Hello. No, we have lost you. Not okay. Yeah. Soumen, you are there but not visible. Yeah, now it's okay. But now your voice is not coming. Make yourself audible.
Now is it okay? Voice is coming?
Yeah, now it's okay. Yeah, everything is okay now. So it's our pleasure to welcome Dr. Soumen Shah. Throughout this FDP, we did not have a very complete session on the quantitative issues. And all participants have requested a lot for having something on the quantitative issues. It's our pleasure that we have with us Dr. Soumen Shah. Dr. Soumen is a close friend of mine. Presently, he is Associate Professor, Dean Examination and Registrar, Master School of Management, Meerut. Besides being a PhD in Economics, he is an MSc IT, MCA, PGDCA, a number of other degrees as far as computer science is concerned. He has completed 2 major projects as expert investigator, which were funded by LBS Academy, IAS Academy, Missouri. He has helped the 12 supervision of PhDs as expert supervisor, and he has 9 and more papers published in journals of national and international repute. He's a man known for his statistical and analytical techniques. It's my pleasure that we have with us Dr. Soumen. I welcome Soumen, and today we have something very new even for me. I was hearing the first time when we had a discussion on the topic AMOS. Probably I'll be listening it for the first time. So it's my pleasure to welcome Dr. Soumen for structural equation modeling through, AMOS.
Over to you, thank you. Thank you. I think I should off my video so that the bandwidth problem can be minimized.
Yes. You can off
or it's okay.
No. You should off it because there is some net issue from your side. So you should off your, and
okay.
You can on your PPT if you have to show.
Yeah, I'll go for the PPT only.
Please see that now you can present now.
Give me 1 minute to share the content.
Now see, now the options must be in front of you.
Yeah.
Yeah.
Okay.
I think you should make it full screen. Yeah.
Yeah, I have clicked. So, good evening to all of you present here. Without wasting time, let us start with the topic that is called structural equation model. For something with AMOS software, we will go for the path diagram. In structure equation modeling, we have to have some assumption of normality, outliers, model identification, and this has to be discussed in this session. We will go for the model fit and modification of the model, and we have talked about we will talk about the model validation. Here Gaskin's model verification tool is being used, will be used. Then we'll go for the measurement model and structural model. We will have to have the concept of the standardized and unstandarized estimate. We will talk about the interpretation of B, beta, and the R square. That is all about the results and reporting of confirmatory factor analysis. That is called CFA. We will talk about the modification, or sorry, it is meditation and moderation effect. That is when some other factor will affect the situation. This is called meditation and mediation effect. And then we will go for the data imputation for latent variable. We will talked about the normalization, that is how to normalize the value, how to find the z-score, and so on, right? So let's talk about structural equation modeling. What do you mean by this term? Basically, structural equation modeling is a multivariate structural analysis, which is a technique that used to analyze the structural relationship. When we are talking about normal regression analysis, there we have a variable which depends on several other variable, and then we have the concept of regression analysis. Simple. But here in structural equation modeling, it is not a single statistical technique. It is the integration of the various techniques which are called, number one, measurement theory, the factor analysis, which are called the latent variable analysis. Then path analysis, regression also is being a part of this structure equation model, and we have simultaneous equation through AMOS. In this session, I'll discuss about the concept of structural equation, analysis, or the analysis of moment structure, or it is called as causal modeling also sometime. Modeling, that is SCM, the latent variable we for integrated in this structure. It is something far beyond the analysis. Still means also as convert. Now the concept is, why structure equation modeling? Why should we use this model? Why should we use this concept of structure equation modeling? This method is preferred by the researcher because of these points. Number one, estimates the multiple dependence in a single analysis. That is multiple and interrelated dependence. Remember the term, the interdependence. It involves complex and multifaceted or different aspects of the constraint. The constraints are called multifaceted constraint. that are measured with error. That is, for example, we are talking about an intelligence. You measure the intelligence. The intelligence are of various aspects are there. So we can measure with a single value. Right? So what to find the intelligence of a person? What should I do? We should intelligence, so that the different aspects in aspects to be considered here. In the same way, social capital is from where we can have the concept idea of social capital. Next is the specific variable and have dependent and parameters. Here is here in this diagram you can say if we are talking about illness depends upon exercise, hardly, fitness, and stress. These are the four factors which will impact on the concept, which will impact on the construct called illness. Now the question is, if we are talking about exercise may be of various kind, various type of exercise are there. You can say the physical exercise. When we are talking about physical exercise, it would be free hand or more like that. So you can have the root of exercise. In the same way, it is hardy, and then whether you hardy or not, and then it is again mental fitness and the physical fitness. So here you can see these are all variables are right. Another part is that when you're talking about exercise depends upon exercise affects the fitness of a people. Exercise depends upon fitness of the people, and the same time fitness depends upon So there you can see there is a relationship, that is exercise then fitness. Exercise, if you are going for exercise regularly, you will be fit, and if you are fit, then illness will be. So there is a relationship, but it is a system of relation. Or maybe measured by the normal relation, right? And here also some mediator effect and moderator effect are also being considered. If you're talking about mediator or moderator, here fitness is a mediator because it is like a middle value which moderator means which may not be in the middle post like fitness, but it affects the system. Like if we are talking about exercise depends upon illness. Now sometimes you can say if you are too harder exercise will make you ill. Say age is then if you go for more and more exercise, your body will be fit, and then you can go for you will have a you will have less illness in your body, right? So this is the concept of structure equation modeling, and that is why we are using this model. There are various softwares which are being used to find that is to go for this modeling. Among these, the AMOS, that is called analysis of modern moment structures, are important and being regularly used. or sometime R or SATA has also been used. So many softwares are there, but basically this AMOS is being used frequently. So if you don't have the AMOS, you can download it for the trial from the IBM. If you link, then you can website. The website address is given here, or you can search from IBM website. So this is 14 days trials are available there.
Soumen sir.
Observe variable.
Soumen sir. Soumen sir.
Hello. Am I
Soumen sir, what
audible?
happens is that yes, you are now audible, but your voice is cracking. Sometimes it goes off, and sometimes it comes.
Okay.
So I'll keep on telling you, because in between your voice cracks. I think some net issues are there, as far as because the voice comes and goes, comes and goes.
Hello.
Hello.
Is it okay now?
No, now it's okay. It went away. We could not hear it. Whatever you were saying in the last slide.
Okay. I'll repeat it. I'm repeating it.
Okay.
From here, structural equation modeling. Let me tell you again. Structural equation modeling basically is not a is a multivariate structural analysis where concepts are being integrated together. Here, integration 5 elements like measurement model, the factor analysis, the path analysis, the regression analysis, and simultaneous analysis is being integrated in the structure equation modeling. Okay, so it is not a single technique like what we have used in used for regression only. In regression, so now the question, why structure equation modeling? हम क्यों करते हैं structure equation modeling? हम क्यों इस्तेमाल करते हैं? It estimates the multiple and interrelated dependence in a single analysis. For example, here I have given an example of illness. Illness depends upon exercise, hardy, fitness, and stress. So these are the 4 factors which affects the illness. Now the concept is, if this is the situation, then it is simply a regression analysis, what we have learned earlier also. But the concept is here, if we are talking about exercise, so exercise may have several factors, or it cannot be measured directly. I can say exercise cannot be measured directly. It has some several aspects. Many sides of this exercise is there. In the same way, fitness have several aspects like physical fitness, mental fitness, and so on. So when we are talking about physical fitness, now the question is how to measure measure whether you are how much fit you are. So in that case, we have to measure by different other questions. In the morning, how long you went for the exercise, walking, and so on. So what I mean to say is fitness maybe is of different aspects that is called say physical fitness and mental fitness. Now the question is, if we are talking about physical fitness or like mental fitness, so you cannot directly measure the physical fitness also. So when we have this type of variable which is not directly being measured but can be measured by using some other variable, other observed element, then it is called the latent variable, right? So it is simply a system of relationship rather than the dependent variable and a set of predictors like previous. So it is a system of relationship. How it is a system of relationship? Because to be fit, so this depends upon how much exercise you are doing. Now the question is, illness depends upon fitness. So illness, how will be, that is whether you will be frequently ill or not, it depends upon how fit are. So exercise may directly depends upon impacts on illness, but in the same time exercise indirectly through fitness will affect the illness or the illness of a people, that is how much ill the person will be. So this is the concept of mediator. Mediator means fitness, stress here are the mediator which mediates the model or mediates the relationship, right? Am I audible, Dr. Mahajan? Hello?
Now it's okay, sir. Now it's not
Hello?
breaking. Now it's okay. Now it's not breaking.
Okay, thank you. So and moderator, the concept of moderator is like that. If we are talking about the age, you cannot say that exercise will make you fit. It depends upon your age sometime. Like the exercise, the relationship between exercise and illness is there, but a moderator or is there, that is the age group. Now the question is, if a old man is exercising more and more and more, sometime it would be harmful for his other body parts, legs or something like that. So that means to say is, it is sometime recommended by the doctors that if your age is this much, you should not go for this type of exercise. So here sometime reverse effect will also be there, which is not, that is, you cannot say that age is a, you can say that age is a moderator here which moderates the relationship between exercise and illness, right? Now it is simple. Different softwares are used for AMOS, for structure equation modeling, and among which AMOS is most frequently and most easily available. Sorry, not you can say easily available, because it cost around 72 or like dollar like that. Easily available software is R sometime, but R have problems also. Problems, I mean to say, have some disadvantages also. So AMOS is frequently used software where if you don't have the software with you, so you can download it from the IBM site, which is available for 14 days. Now the concept of variable, as I told you, when a construct is to be measured, for example, some social scientific concepts are there which cannot be measured directly, which cannot directly observable. For example, I have quoted earlier also that here that is exercise or illness cannot be measured directly. So in this way, some observation, some variable cannot be measured directly. Like he have quoted the examples of in intelligence, social capital. If we are talking about intelligence, there are several different part of intelligence are there. It cannot be measured within a single question. So this are to be here we will have to use the concept of latent variable. Using single measure not adequate cover the full conceptual map. For example, if we are talking about the how intelligent you are, that is what is your intelligence. So intelligence may be measured in terms of cognitive or non-cognitive intelligence. Now the question is full conceptually how to calculate or how to get the value or how to get the observed value of intelligence. It cannot be measured directly. So or sometimes a single question cannot be used for a particular to obtain the values of particular question or particular variable. So this makes them hypothetical or latent construct. So these type of constructs are called the latent construct or latent variable, right? We can measure latent variable using observed indicators. For example, if you are talking about intelligence of a person, so इसके लिए for that we have several observed indicators, like how much marks you have obtained. This is one part. Second is what about your IQ. So to know the IQ, there are several other tests also, not like how much marks you have obtained in math or maybe in English or maybe in science, like that. These are the cognitive approach. So here the values which can be obtained is called the observed indicator, that is observed variable. So here the concept of latent variable and observed variable has been discussed. We can think of variable or variance of a questionnaire item as being caused by the latent construct we want to measure and the other factors, that is or unique variance. For example, here I have put in the example here. If we say x is equals to t plus e, that is when the concept is from the regression analysis, where you can say that true value, that is when we get the value, say if somebody says that this is the quotient or this is the quotient of, this is the value of intelligence, this is the index of intelligence, or maybe a single numerical value. Now the question is, it is observed. Now the question is, this observed value may have or must have, when we have collect it from the field, it should have some true score, that is the latent constraint, and some error also be there. For example, if you have some multiple choice question, so the concept is either you answer the correct, or sometimes you don't know. If since there is no negative marks, I put somewhere else, and sometimes it be good and it's correct, or sometimes it may not be correct. Or sometimes you say among the 4 options, what you can do, you can omit the 2 options with your knowledge, with your intelligence, and the remaining out of 2, 50-50 chances are there. Out of 2, you have choose any one, because out of 2 you are confused, you don't know. So when we collect the data, it is having some true score, that is called latent constraint, and plus an error concept. Now the question is, in this equation, you can see, if we are from mathematics, or sometimes no need to mathematics, because it is what we talked about, the simultaneous equation, where we have x equals to t plus e, where two variables are unknown here. One is x, one is t, is e, right? Because x value is an observed indicator, which is manifest variable. This variable is also called the manifest variable. This is observed indicator. So one equation, 2 unknown, it cannot be solved. So minimum 2 equations are to be needed to solve this, right? So this is the concept of multiple latent variable, and the concept of solving the multiple indicators, right? To go further, let me take an example of a concept of a HR topic. Here it is, I have team performance. I have to measure team performance. Now, how to measure the team performance? So it is a latent variable, because you cannot say that team performance can be measured within a single question. So what should we do? We should find how to measure team performance. Here I have two observed indicator, that is scale of innovation and the intra-group conflict scale, SOI and ICS, right? These are the two observed indicator from where we can get the knowledge whether the team performance is good or bad or like that. That is, we can have some numerical values there. Now the question is, if we are talking about SOI, scale of innovation. So scale of innovation have several, so to find what is the scale of innovation of this team has. So you have to have several questions for that. Here it is in the diagram you can see. In the diagram you can see here we have 1, 2, 3, 4, 6, 7, 8, 9. So I have given 9 question. Question means the questions on the statement in my questionnaire. I have asked 9 questions to know the innovation, scale of innovation of that particular team. So I have 9 questions for SOI, and in the same way I have 8 questions for ICS. Now you can see SOI is a latent variable. Sorry, team performance is a latent variable which can be measured by SOI and ICS. Now again, SOI ICS cannot be measured within a single question. So what should I do? We can go for several questions or several statement and give maybe what we can say is, maybe you can give for Likert scale, like whether you are absolutely, that is you are agreed or disagreed, like that. That is, you can collect the data of observed variable. These are called observed variable, right? And again, another variable I have taken here, that is cultural quest. So cultural quest is again observed by metacognitive quest, cognitive quest, motivational quest, and behavioral quest. Those who are not from HR, because I am also not from HR, but this example is good to explain, so I am taking this example here. So basically, simply you can say cultural quest depends upon 4 variables: variable 1, variable 2, variable 3, and variable 4. Now this question is, variable 1 cannot be measured within a single question. So for that I have asked maybe 1, 2, 3, 4, MQ1, MQ2, MQ3, MQ4. 4 questions are to be asked to the respondent, and they have given their answer. Among these 4 questions, we are having a model which is called I'll tell you later about this model, where by which we can get the answer of the value of latent variable here, that is MQ. In the same way, if we have MQ, COG, MOT, and BEH, the value of all these 4 factors, then from these 4 factors we can analyze the value of CQ, right? So if we are talking about this, if we are talking about this portion, so this is a model that is technically called, it is a measurement model. In the same way, we have another model here also, then another variable. So this is a single regression equation. You can go for regression analysis for these, you can go for regression analysis for these, but here structural equation model is 1, 2, 3, 4 regression equation, and after that getting this value, a regression value, that is value of this MQ, COG, MOT, and BEH, you can go for another regression equation here for Q depends on MQ, COG, MOT, and BEH. So here it is the complete path where effects of cultural intelligence depends upon team performance. Sorry. Team performance depends upon the cultural intelligence. So the team performance how the team perform, how that is whether the team will perform good or not, it depends upon the cultural quest. Now the cultural quest of the team depends upon MQ, COG, MOT, BEH, right? These are the four factors. MOT, COG, MQ, COG, MOT, and BEH. Char factors are there, right? Now you cannot determine the, you cannot get the direct value of MQ, so we can have an regression model here. So to find the MQ values. In the same way, all the model that is all called measurement model 1, measurement model 2, measurement model 3, 4, 5, and 6. 6 measurement models are there, and if we accumulated all this model, all this path, then you can see that this is called path analysis, right? That is called path diagram. Now let me introduce the software that is called AMOS concept. In AMOS, when you open the AMOS, you have this type of interface there where you can have the menu bar, we can have the menu bar here, we can have some tools here. Then we can have input path diagram, output path diagram. This is called parameters format window. This is called computation summary, and it is called the current directory. The different files are there in the current directory is being shown, right? The what is a AMOS software also. Let me introduce first. AMOS toolbar. The AMOS toolbar consists of several tools which will by which we will make this diagram. That is to making this diagram. So these are the tools for observe. To draw the observed variable, we have to use square. For drawing the unobserved variable, that is the latent variable, for have this tool to draw the error values. You can add the error values by using this tool. Here it is. We can go for the relations or the regressions by providing this arrow, and to know or to calculate the correlation, if we have to go for the correlation or between the two variables, then you can use this tool here. Here it is the tool. So many tools are there. Before starting it, let me go for the AMOS. So simply it is now, no issues. New, this one new. So when I open the what we say AMOS software, it is look like that, right? So the question is how to draw. First of all, we have to draw the concept, and then we have to go for put the variable there in, and then we can run or we can go for the calculations, right? Now let me see how to go for the diagram. You have to select this draw latent variable, or add an indicator to an latent variable. So I have clicked here, and now if I click here, now you see when then it is a latent variable. Now on the same, you will get the observed variables also. Now I 4 click here, I have clicked 4 times, so 4 latent variables are being shown here. Now remember here, I'll tell you later, no issues. Now the question is how to rotate it. If you would like to rotate it, so here it is the rotation, rotation tool. So if we go for the rotation, you can rotate it as per your choice, right? And same way I can copy the same by using this concept duplicate object, right? So for duplicate object, select this. This is preserve, that is all together. That is here you can see the values are all together. So when I select this, so this is move object. So you can move the object. Now the question is, Now whenever I click it, it will be rotate, right? Now the question is, if I move, now if I select here, that is deselect here, so it can be moved here like that. If we select this tool, when I select this tool, it will move entirely, right? So these are several tools. When we you go for the practice and practice, you will have several options are there. Now another tool, this is called this tool is called change the shape of the object. Now you can see, if we have to reduce or enlarge the shape, you can go for this. Now duplicate object, click here and now click here, so now you can have the duplicate object. So how can you get the duplicate object? Click on the duplicate object icon and then drag it, you will get the duplicate one, right? So I have duplicate object here. Now I have seen, say for example, I have 3 variables. So cross means erase object. So I have erased the same. Now this tool is called touch up. I will let you know later. Now what I can do is I will rotate it. For example, it is rotating like that. Let me zoom in. So these are 2 variables, right? 2 latent variables I have taken. Now the question is how to observe variable report. For there, here it is a concept which is called select data file. So after drawing this, I have draw the two regression variables, or you can say measurement model. I have to add it, that is go for select data. Now click on file name, it will open the file. I have so many files are there. Online education, not this one. Workshop to analyze the AMOS. We have several files here. For example, say I have taken this file only. I have added the file, that is the data file I have added, right? You can see the data file what you have added from view data option. The file, the Excel file or the SPSS data file will open. I have clicked OK here. Now here it is called list of variables in the data set. So in my data set, how many variables are there? I have so many variables here. So many variables are here, right? So among these, for example, say MQ1, MQ2, just drag and drop MQ3 and MQ4. So 4 latent variables of MQ are there, right? And in the same way, I can say here motivation. Sorry. Let me. No issues. I would like whether MQ depends upon maybe some other factor, just to see. For example, say COG1, COG2, and COG3. Say so there are 2 variable. One is the MQ, another is COG. Say for example, don't go for the actual one. In my example, I have put it just to know how to draw it, right? So now I'd like to know whether these 2, right? How to give the name of this latent variable. You can go for double click it. You can double click the latent variable. It will open the object properties. You can go for MQ. Right, this is our name of the variable. It is MQ. Double click right here, COG. So this is the name. I'd like to know the relationship. If we have to have the direct relationship, I have to put here. And if you would like to know about the correlation coefficients of this, then yes. So then we can go for this. It will not work because I have done it like that. So this is called the multicollinearity. In case of multicollinearity, I will discuss it later. This will show you the correlationship between these 2 variables, right? you'd like to know the direct relationship between MQ and COG, click here, like MQ depends upon COG, right? Now, here we have these variables. These variables are the error variable I have discussed. So how to put the name of the error variable? Either you can double click it or put the name. Otherwise, there is an option in plugin. It is name an unobserved variable. So it will gives you all the variables which are not given, like E1, E2, E3, E4, E5, E6, E7. So all the other variables is to be, the name of the variables is to be given. Right now what to do? We have add the data, we have go for the, and then there is an analytical properties, that is analysis properties. Click on analysis properties. We can have several concepts. Normally in our AMOS, generally we will use maximum likelihood estimator to estimate the values of this MQ and COG and this relationship. You can have the output. What are the outputs you need depending upon your requirement? For example, I told you that we will check whether the data normalize or not. That is assumption. In assumption, we have normality of the variable, normality of the values or the data are to be there. So we have to check it. We have to click here. So many variables, so many options are there as per your requirement. And you can go for must for the squared multiple correlation, because of to find the relationship of this structural model. This is to be required for analysis. If you go for the other that is modification, then you can go for the modification index and so on. This will I'll discuss it later one by one, because it would be difficult to know or understand within a single step. So this is the in which I can develop the model like that, right? For example, in this way I have developed this model. Put here no. Now here to the concept what I have talked to you, I have told you in today, that is CQ, cultural quest, depends upon MQ. Cultural quest depends upon MQ, MOT and BEH. 4 factors are there. In the same way, TP depends on 2 factors, factor 1 and factor 2, right? Now the question is whether TP, that is team performance, how team performance depends upon CQ, right? So initially what we have to do, we have to add the variables. I have add the data file. I have already added. I have clicked here and then go for the file name and add the data file as per your requirement. So after adding this data file, click here for the analysis. I have initially checked, not initially so much, सारे एक साथ नहीं दिखाते. Say no issues. Click on all these factors, all these output options, right? And go for the estimate. It is maximum likelihood estimator is to be estimate. Okay. Now after that, click here. That is calculate estimate. What it will be, when I click here, it will take some time to analyze. Here you can see it is analyzed, and here you have the output. I mean to say, this is the window which will show you whether it is the origin, that is answer. I mean to say, not the detailed answer, but a overall answer is there, where the chi-square value is showing it is 3685 and like that. Right, maximum iteration, how many iteration means how many times it will work for. 13 times it will go for this, all the dependent variables and independent variable, all the regression models is being analyzed 13 times, all this total model. So if we think about that, you will have to do within a concept of regression analysis, then it will take maybe 13 months to work with, right? or sometime if we are efficient enough, so it will take maybe of 13 days to work with for one time analysis, right? So this is the concept of what we say our AMOS. Here when I click here view text, it will output. When I click here view text, it will show you output. Just a minute. You can see the initials. It shows whether this model is okay or not, whether the model have some problems or not. For example, if the model have some problem, it will be showing here, right? So okay, sorry, it will be showing here. Now analysis summary, it is the summary है ना, कब हमने बनाया and what is the time I have created this. Notes of group, I have a recursive model, a sample size is 358, like that. Variables, what are the variables are there. We can have importantly, I have to tell you, notes of the model is important. It is important to go for the modification indices. These modification indices are there. I'll discuss all the indices, all the variable regression weights. I'll discuss all these things later on in my PPT. What are the implications and why we should do, and what are the things to be analyzed. And then estimate, go for the estimate. Now you can see here, for example, see this portion. This is your single regression of MQ. MQ depends upon MQ1, MQ2, MQ3, MQ4. I'll not say depends upon. That is to find MQ. MQ is a latent variable. To find the MQ, we are having 4 variable, that is MQ1, 2, 3, and 4. And here it is estimates. We will have the beta value. These are called the beta value. These are standard error. And this star, triple star means 0.000. That is confidence, significant level, which we have talked in regression analysis. So this is our value 0.000. That is all the values, all the observed variable have significant impact on MQ. So everything is okay. Or you can see CR, that is critical value and a critical ratio. This is our chi-square values of each and every relation, right? So this is called maximum likelihood estimator. This is estimation. Now you can have some standardized R square. Just standardized R square, I'll discuss it again my presentation, and we'll talk about how to what we say, how to generalize the, or how to go for your conclusion in this, just to see how the results appear. So now you can see here MQ1, MQ2. Here you can see this is the regression, standardized regression weights, and I'll discuss it later what you mean by standardized regression weight. This is important. And for every model you can have, even TP and CQ, it is having 0.653 and so on. That is how the CQ and TP are related. That is how much CQ affects on TP, kitna percent affect karta hai, right? So it is intercept. We have some correlations also. Different correlation is to be analyzed also. I'll discuss why we have used only this correlation only, not for others. It would be discussed. So this is the output. So many output concepts are there that cannot be discussed within a single session, but we will try to cover important analysis only, right? So this is about our concept of the AMOS. Okay, so now let me start with again the concept. That is, when we are going for the structural equation model, you should have the data with you, which will can be used for this model. That is, the data should have some characteristics to work with structural equation model, right? So if we are talking about the what are the characteristics, what are the assumptions of this particular structure equation modeling, these are some assumptions I have talked about, and have to check whether your data is fulfilling these prerequisite assumptions or not. If your data is not having these characteristics, then you cannot use this data for your structure equation modeling, right? One is the multivariate normal distribution. That is your multivariate normal distribution means that distribution of your data should be normal. We'll go it in detail. Linearity, your relation should be linear, or you have to assume that your relation should be linear. Normally क्या होता है, in most of the cases of social science, the relationship is non-linear relationship is being found, but it is to be assumed that your data, your relation among the variables should be linear. Outliers means you're free from outliers, means extreme values. Your data should be free from outliers. But when you are using the variables, that is the value of the variables in a Likert scale, so you cannot, your value should be in between 0 and 5. There should not be any outliers. Outliers means extreme value. There should not be any outliers. But here in that case, where outliers means inconsistency of your data set, right? We will go for the sequence. Another assumption is sequence. There is a cause and effect relationship must be there. It is not like that you can go for the structure equation modeling with any of the variable. You can take any variable and go for the analysis. Not like that. There must have some theoretical construct that is about the sequence of the model. The sequence of the causal relationship must be there. There should have observed covariance is assumed to be true. That is, the covariance should be there. How to discuss about covariance? Covariance means when two variables are impacting a single variance, then the what we say, the merged value, that is if A and B depends upon A and B impacts on C, then there is a combined value of AB which affects the C also. That is what we call the assumption of covariance. Uncorrelated error terms should be uncorrelated, right? These are the assumptions. The question is how to test the normality. Here the concept of normality. The value for asymmetry, or the skewness and kurtosis value, that is, if your kurtosis and skewness value is in between -2 and +2, that your distribution is you have a normal distribution. However, there are other tests also for normal distribution, whether the data is normally distributed or not, by using the SPSS. Here go for this concept also. If your skewness as kurtosis value is ±2, then you can say that your distribution is normal, right? Now you can see here in output, where it is. No, it is not your output. This is where it is output. No issues here. No, this is the output, right? Go for normality. Minimize model estimates, notes of sample, normality, assessment of normality. So when I click here, you will get the skewness value. Go for the kurtosis value. The skewness and kurtosis values is to be checked and find whether skewness and kurtosis. Right. So in our output file, you will get these figures. So here is my PPT again. So if your skewness and kurtosis from output file is to be checked, and if it is lies between minus, the distribution is normally distributed. If one or two variable are not normally distributed, what you can see is, for example, if say this value variable ICS8 is not normal variable from there in your model, right? Then test of outliers. List of top 100 observations ranked in order of their Mohalnebis distance. This concept Mohalnebis distance will be calculated by using AMOS. AMOS will gives you the 100 Mohalnebis distance to top 100 Mohalnebis distance value, to find whether there is how much outliers are there in your in your data, right? Since the rate is measured so here Mohalnebis distance gives you the inconsistency of the collected data. Inconsistency of the collected data means whether your data is consistent or not, right? Inconsistency and creates the problem of conversion validity. So I'll take it told later on about this concept conversion validity. So if your data is having the inconsistency, then there will be a problem of validity. So we have to check whether your data is valid or not again later on. So first of all, you have to go for the inconsistency of the data. Then we can go for the convergence test, right? Here, which distance you can see again observation number, distance square, and then P1 and P2. This is the output. Should I show you? Out. Here it is. Mohalnebis distance modification index. Modification index, no, not here. Mark distance, here it is. You can have the table where it is shows the number of observation number, Mohalnebis d square, and P1 and P2, right? So I have pasted here. So now the question is how to remove the outliers from your how to remove your inconsistency from your data. It is said that if your P1 value and P2 value are less than 0.05 data, here it is said that 257, this is your number, right, row number, right, serial number of your data. So if we remove, that is, we should have to remove the 257 number data or 119 number data and so on. These are the number observation number, right? So if we remove all these, maybe 17, 18 observations are there. So out of 500 or 600 data, like that, if we remove all these 18 or 17 data, then it will not be too much problem therein. So it is recommended that you should remove these data value from your. After that you will go further, right? So this is this will remove your inconsistency of your data, right? Now model identification. Now the question is again, concept is model identification. It is whether your data model, I have talked about data in up to this point. Now I am talking about the model. जो model हमने बनाया है, the model I have derived is identified or not. What do you mean by identification? I have told you earlier also. Say I have an observed variable x, which is equals to T plus E. What is mean by T and E? T is our true score, that is called latent constraint, जिस पे हमारा focus है. The focus is on latent constraint, and the error term, right? So here I can see the two variable, one variable two, sorry, the T and E, which are unknown, and equation. So single equation, by using single equation we cannot get the value of two variable, right? This is जो simultaneous equation solving जो हम करते हैं, this is like that. So in that case I need at least two equation to solve it, right? So this is what I call model identification. Now the question is, in our analysis, several how to count how many variables are there, or how many equations are there, how to count, because it is too vast, right? See, I'll show you. The AMOS output, right? Where it is notes of model, right here you can see. It says that number of distinct sample moments are 740. Number of distinct parameter to be estimated 190 are to be calculated. Remember, 119 variable is to be calculated, right? So degree of freedom is 621. No need to know फिलहाल के लिए. So you have how many distinct sample moments are there? 740, and out of these sample moments you have to calculate 119 parameters to be calculated. So minimum you have to have 119 equation to solve, because if 119 equation and 119 unknown, then and only then, or maybe the output, maybe it is more than, if your equation is more than 119, then you can say you can get more than one value of a particular, right? So minimum requirement of an equation is 119 equations are to be solved. So here all the model identification. So ये जो AMOS है, AMOS will tell you whether your model is identified or not, right? If it is not identified, in the portion discussed now is show your model is not identified. And how to solve the identification problem, let me tell you. For example, say okay, say I have a latent variable. Now you can, so it will show you here you can see एक one लिखा हुआ है, one is there. So when I talked about here, in case of this that is error term, it will already automatically shows 1 1 1 1 1. That is, it is fixed. The variance of an is being fixed here, like is equals to 1. That is, error value is not varying, right? In the same way, in this latent variable here, it is shown 1, right? And others are okay, that is no values are there. So this is what you can see is concerned. So remember, when I derive this model, the at least one of the observed variable or one of the variable must have a regression weight is equals to 1. Remember that. This is the concept of because it is if we put here regression weight is equals to 1, that means it is to assume that this value of regression weight is 1, and then accordingly the percentage of other variable, other regression weights is being calculated. Remember, I'll let you know later on. How can we show you that? I'll show you the concept again. Remember, at least in one of the variable it should be 1. If it is not there, then there will be a problem of identification. For example, here I can see here it is written 1. Now I click here and get the regression weight 1 from there. Now when I run this with this model, now see, it will show you the model is probably unidentified. In order to achieve the identifiability, it will probably be necessary to impose one additional constraint, because इसमें क्या हुआ कि number of equation इसके वजह से number of variable ज्यादा हो गया, that is variable is higher here. What I do is I put here in any of these 1, 2, 3, 4 किसी में एक में you have to put 1, right? So then if we run it, identification problem. So it will show you whether your data is whether your model is identified or not. Now you can see no error is shown. The answer of chi-square is shown and the chi-square probability is shown here, right? So the concept of it is 622 model identification. Here I have shown you model identification that I have discussed now. When it is your model is not identified, it will show you this message, and after correcting it you will get the identified and the result will be there, right? Model fit. Now the question is whether your model is identified. Now now the question is whether your model is fit or not. Whether your model is fit or not, right? Goodness of fit, that is here model fit is to also been examined. So here it is very much so many model fit concepts are there. I'll not discuss this model fit in very detail, but have to know some the workout concepts. Like here we have 3 type of model fit. One is absolute model, ठीक है, 3 type of model fits are there, and for that different values are there. जैसे for example, if you have more than 102 fever, then the symptoms, this is model fit means if your model is fit, there will be some symptom to be noted, right? The symptoms are just I am telling you in not. The symptoms are the Semean, the chi-square values, the p-value of the Semean, that is probability, would be 0.05. Some other variables, other statistics are there, that is RMSEA, that is root mean square error of approximation. So many other concepts of GFI is there for absolute model fit, and their thumb value, what should be the value, so that you can say your model is fit. If your temperature is say maybe 95, then it would be is maybe 102, and you have to think about it, have to reduce it, and you have to go for other concepts. किस तरह से हम इसको मॉडल को फिट करा जाए, किस तरह से ये रिड्यूस करा जाए, right? So again incremental model fit के लिए you have to go for AGA, CFI, NFI, and in pessimistic parsimonial model fit के लिए it is measured by Semean divided by degree of freedom, that is calculated by this, right? Degree of freedom should be less than 5. The Semean divided by degree of freedom should be less than 5. So don't worry about this concept. Just remember like a index, that is AGFI is an index, EFI as an index, NFI as an index, TLI as an index, and बाकी AMOS आपके लिए काम कर देगा, right? So here are the results and their here are the results of my analysis, and side may I have the X value. That is, example RMR, the accepted value is less than 0.08, and हमारा कितना आया? It is 0.05. So we can say that our data is our model is fit. C mean degree of freedom, it is 2.452. आपको कितना आना चाहिए? 1 से लेके 5 तक आना चाहिए. So किस लिए आना चाहिए? Parsimonious model. C mean degree of freedom should be less than 5, right? So these are the concepts, or several tests is to be done. Or now the question is, हमें कहाँ से मिलेगा? From where I can get it? Don't worry. Model click करो, right? Table wise. For example, it is C mean, degree of freedom, and फिर NFI, RFI, and फिर है F mean, RMSEA, and then other factors, other model fits values are there, right? So about model fit indices. Now the question is, if your model is not fit, सबसे basically आपको क्या देखना है? You have to see this CFI by degree. Important. यदि ये मोटा मोटा फिट फिक्स हो जाता है, if it is less than 5, that is 2, 3, 4 maximum, other values, all the other concepts will be okay, right? If this is okay, then other things may be okay in most of the cases. Model is not fit, so किस तरह से, how you have to reduce? If your data, if your C mean by degree of freedom, here I have 2.452, if it is maybe greater than 5, so how to reduce it? The concept is modification. आपको modify करना पड़ेगा model fit में, right? Sorry, model को. Now the question is, how to modify model? Modification of the model is required. Here you can see some modification index is there, and परसेंटेज. यदि हम इस मॉडिफिकेशन को करते हैं तो मेरा काई स्क्वायर में कितना परसेंटेज जाएगा, कितना वैल्यू चेंज हो जाएगा. इट इज दैट this value, this table is also, again, this table also being there in our output file, right? Just to search it where it is. Now the question is, it is that this E35, two error values. So if we have this concept, this is correlation. मतलब E35 values are correlated to each other, right? So there must have a correlation, and if I correlate two variables, then one is the value, that is value of chi-square will reduce 156. Okay? So chi-square value where it is, this is chi-square value, say 15. That is 1515602. See, ये chi-square value कम हो जाएगा. कितना कम हो जाएगा? It will reduce by 156 unit यदि हम इन दोनों को जोड़ दें, right? In the same way, 58, I have 58, now 46, because if we add this two in correlation, then what happens? One thing is there will be meaningless. E44 के साथ CQ का कोई relation होता है, या if these two variables are correlated with each other, actually it is not agreed. Of course, remember here you can have to do software, but conceptually you have to check also, right? Conceptually you cannot say that कि एक latent variable के साथ एक error variable का कोई relation, वो भी किसी other latent variable की error के साथ relation हो सकता है. So you should not go for this. So but E34, E35, these are in the same construct, so you can add it. E32, 33 इनको जोड़ सकते हैं, and 83 यूनिट घट सकता है. Next E23, E24, ये भी एक ही latent variable का part है, so 76%, 76 point घट सकता है. E5 and E6 घट सकता है. Now you can see here E23, E24 are to be related, वही correlation वाली जो मैंने वो दिखाया था. These are the 4 identified. I have identified model here. Before modification, it is chi-square value were more. Now if we add these values, then what add this, that is if we introduce the correlation coefficient, that is the intercorrelation between these two, then you have your model will be more fit, right? Okay, so the difference, let me show you first model fit. Here you can see C6, you can add 5 or 6 हमने add is draw covariance. So I have draw a covariance in between these. In the similar way, I have draw the covariance of other also, right? So after covariance drawing, before drawing this covariance, what is the result? And after drawing this covariance, what is the result? Is being shown here. This is our model fit. Before mean that is chi-square value. So, sorry, not chi-square value. Chi-square value is this one. Before chi-square value, before that modification, chi-square value is 2011. But after that, it is 1515. So it has been reduced. C mean by degree of freedom is reduced by 3.235, and it from 3.235 to 2.452. That is again because of modification. What happened? Our what we say, our model become more fit, right? So and if this is okay and this is working well, then the other, no need to think about the other. Most of the cases, other things are okay. Now the concept of validity. So if we are talking about validity, is very important, because most of the researchers work without thinking whether they are doing the valid work or not. So validity is very much important, right? So validity here are of 3 types. One is content validity, आपके content ठीक है या नहीं. Another one is construct validity. Content validity, adequate coverage of the subject. यदि आप चाहते हो, if you would like to know about the intelligence, so all the aspects of intelligence are to be covered or not. This is important, right? If you take 1 or 2 concept of intelligence and then you can say my work is valid, is not coverage of the subject. Having of adequate sample also. आपका sample size ठीक है या नहीं, that is also important, right? So this is about content validity. Now is construct validity. ये जो मैंने model fit करा है, इसका construct validity, ये जो हमने बनाया है, whether it is okay or not, whether the model I have derived is okay or not. If I say ये जोड़ दो, ये जोड़ दो, ये जोड़ दो, now the question is ये तो मैं अपने perception से, this is my perception that कि team performance, these questions required. This is my concept. But sometime I can say that this is the statistically it is not true. If somebody say that, for example, यदि हम कहते हैं कि if the number marks obtained by a student, if the 99% marks obtained किया है तो बहुत अच्छा बच्चा है, this is not okay sometime, right? So what is about is कि construct मैंने बना लिया कि this marks obtained by the student is my construct. Now I have to construct of the intelligence of a person, of a student. So it is it may not validate our construct in some cases. जब मैं कुछ करने दूंगा, if we give some work to that particular candidate, then it will not show you the same or maybe the similar similar answer to me as I expected, right? So construct validity is important. The theoretical construct of cause and effect actually represents the real world scenario they are intended to the model. Remember this point, right? So construct validity, next point is to be remembered, there are two types of construct validity, right? One is convergent validity and discriminant validity. I'll discuss it one by one. So it is to know about the validity, whether it is construct validity is there or not, and to know, to talk about दो तरीके का. Number one is convergent validity and number two is discriminant validity, right? Convergent and discriminant are often demonstrated by correlation of the measures used by convergent validity and discriminant validity together demonstrate the construct. Let me discuss about these two terms, convergent and discriminant validity here. Convergent validity occurs, remember, when measures of constructs that are expected to correlated to do so. Where measures of construct that are expected to correlate do so. यदि मैं कहता हूं कि marks obtained by the student is correlate to the IQ of the person, that should be correlated. Not correlated, if I said that if it is not correlated, then your data is not valid, right? So convergent validity means when measures of construct that are expected to correlate to, right? So how to know whether it is your value, your data is having the convergent validity or not, your model is having the convergent validity or not. एक तो उपाय ये है कि you have to have your own brainstorm and have to go for कि सोचो कि ये क्या हो सकता है and so on. So these are sometime क्या होता है कि conceptual होता है. That is when we discuss these things with some person to determine where data have a convergent validity or not. Sometime it will be biased like that. If we are talking about if somebody are not very much what we say, somebody is not very much computer like mathematical savvy, equation savvy, so they used to go for the graphical interpretation. And as you know, when we are talking about graphical, it gives you the information not exact, not point, right? But if we go for a calculation or equation, this will gives you the exact and even the marginality also, right? So here convergent validity can be measured by using 3 index. Convergent reliability, CR, आपको CR देख, that is CR value is greater than 7 or not. AVE should be greater than 0.5 and CR should be greater than AVE. These are value, we will get it from this AMOS. इसी AMOS से आपको ये तीनों वैल्यू मिलेगा और ये AMOS आपको बताएगा whether your data have the convergent validity or not. Nothing to worry, right? Nothing to go for the brainstorm or the biasness of that is what we call the human biasness, right? This validity, discriminating validity occurs where constructs that are expected not to relate do not. That is where constructs are expected not to relate do not. That is जिस construct को आप चाहते हो कि for example I have two construct A or B. I would like to difference between these two A or B. जैसे मैं यदि बात करता हूँ कि जैसे फिटनेस, और जैसे मैंने अभी पहले सब एग्जांपल दिया था, दैट इज फिटनेस के साथ दैट इज एक्सरसाइज एंड फिटनेस. इफ वी आर टॉकिंग अबाउट द रिग्रेशन एनालिसिस, द इनिशियल कंसेप्ट जो हम अभी तक करते आ रहे हैं, where I said that fitness and the exercise are two independent variable. They are not related with each other. Objective, this is the basic assumption, and then we go for the regression analysis. But here importantly it is, you can say कि इस दोनों में कोई रिलेशन था, लेकिन what I have done mistakenly, we have got for assumption of independent factors, right? So here it is, remember कि discriminating validity आपको बता देगा whether your construct is, two constructs are expected to related or not. ठीक है, इसको इसके लिए क्या करना है, इसके लिए आपको चेक करना है कि आपका AVE and maximum shared variance MSV, whether your AVE greater than MSV or not. If it is greater than, and again AVE greater than ASV, these two concept is there with you, or these two value are having this what you say इसी तरीके का है, whether your this equation or this inequalities follows this two inequalities, your data follows this in two inequalities, then your data or your model is out of free from discriminant validity, right? इसमें let you know one thing here. जब मैं इसकी बात करता हूँ, when talking SOI, say this is SOI, are having this 5, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9 variable. I must say these observed variable must have some having the same, or must having the same correlation or correlated. I can say this to be correlated, because all are dealing with about SOI. Similarly, if we are talking about another variable, these variables are measured by using these variables, measurement variables. So all these measurement variables have some relation among these. If I say कि मुझे आपका cognitive skill जानना है, तो हमने क्या करेंगे, I'll take the marks. If your marks in physics are good, your marks in chemistry will also be, your marks in math will also be, and somewhere, because good students have the good marks in all the subjects, right? So when I talked about the cognitive value, so it is marks. So all the subjects must have higher and higher marks, or the nearby marks, that is correlated marks. This will be not that कि इसको physics में तो मिला है 30 और mathematics में मिला है 90, not like that, right? So there must have some correlations among them. But in the same time, I should not say कि these two variables are very much correlated, because this is in and this is in another separate concept, right? Here is the concept of convergence discriminant validity, right? Now, how to measure these values, CR, AV, validity कैसे हम टेस्ट करेंगे, right? So see, AMOS का इस आउट नहीं होएगा. इसके लिए I have to introduce one term that is called, चाहिए इसके लिए, है ना, this is called Gaskins plugin, right? ये basically आपको, the plugin name of the plugin is called Master Validity Tool, that will be available in that has to be implemented or add to your AMOS from a website that is called Stati. This is a statistician जो कि बहुत famous statistician है, जो एक बनाया है, that is they have he has created a add-ons of AMOS जिसके द्वारा directly you can get the master validity option, model validity measures, right? So here is our output. After clicking here, go for master validity. When I click the master validity, open a master validity concept here, right? So I show you here. This is that is model validity. Before calculating the model validity, remember, before calculating the model validity, आपकी जो मॉडल है, the model different order follow करता है, right? Here I am talking about zero order. What do you mean by zero order? You can see here, बीच का कोई भी variables नहीं है. All the and the first order latent variable, the zero order latent variables is being taken into account, right? Sorry, right? So all other CQ or TP, team performance, or CQ is not being taken into account. So all the simple variables are taken, and all the variables are related. सबको एक के साथ दूसरे का relations correlation कर दिया मैंने, right? So after doing this, if you have to go for the model validity of zero order, right? So ये check करना, this is the value of CR, VE, MSV, right? कि ये values का greater है या less है. Validity concept. Discriminate AVE greater than MSV. Check करो AVE greater than MSV or not, right? So this is the which you can check whether your data, your model is valid or not, right? Now after this is zero order validity. Zero order validity में आपको क्या क्या मिला? MQ, COG, MOT, BEH, SOI, CIIS, that is ये all, right? That is another concept, is called second order. This is first order. Now यहाँ पे देखो zero order के बाद second order आता है, first order नहीं आता है. इसका concept अलग है, that will take another session, we'll discuss later if we get time. So here you can say these two latent variable are also being added here, right? जो कि this C, which is a variable, right? You don't know the value of MQ. You know the value of MQ1, MQ2, MQ3, MQ, right? So you don't know the variable MQ. Here I have introduced a variable CQ, जो कि latent variable से impact करता है. That is, if MQ changes, the CQ will change, right? Now the question is, remember this second order ऐसे ही नहीं, like कभी भी आपने बीच में ये चारों को दोबारा मिला के एक और वेरिएबल बना दिया कि this CQ depends upon this, not like that. इसके लिए पहले टेस्ट करना पड़ता है इनको. These four are must have the correlation. यदि इनके बीच में high correlation है, then and only then you can go for the next second order. और यदि नहीं, आप second order में नहीं जा सकते, right? First order is if you have to go for के साथ TP, CQ के साथ TP, and BH के साथ TP, right? Concept of second order validation, right? Now, see, जो हमारे मॉडल है, here in my model we are having, hello, audible?
Yeah, you are audible, sir. You are audible.
हाँ, बहुत देर से जो है ना आप लोगों का कोई रिस्पांस नहीं है तो
now the voice was crystal clear, sir.
Okay.
Yeah.
Measurement model and structural model, here are the two terms. Let us see, very that is self-explanatory figure is there. यदि मैं बात करता हूँ इसके बारे में, that is single, this one. So this is what is called model, right? And how many measurement models are there? 1, 2, 3, 4, 6 measurement models are there. And after this 6 measurement model here I have a model of latent variables. This is a structural model. Hence the name of equation modeling arises, right? So this is the concept of structural equation modeling. अच्छा, अब this is थोड़ा बहुत टफ है, you can say थोड़ा बहुत remembering है कि हमें क्या करना है and so on. Let me discuss about this. एक latent variable में क्या क्या दिखता है हमें. This is the of a zoom figure of a latent variable MQ, right? ये दिखेगा आपको. It will show you two figure, like one is this, that is called unstandardized figure, and another one, right? Let me show you first how you can see the standardized and unstandardized. After running, हमने run कर दिया है और सब कुछ check कर लिया है. All the variables or the parameters and the tests are okay. And then what I do is here the concept of parameters formats, unstandardized, standardized. So here also two options are there. One is view the input part. Here it is path diagram, and here it is view the output path diagram, right? So इसके लिए आपको क्या करना, अभी तक हमने जो बात करी इसमें कुछ नहीं दिख रहा है. You cannot see anything. In MQ, nothing is visible, like I have shown you in the PowerPoint presentation. See here, no values like this 3.1, 1.2, 17.2. No values are showing here, right? In MQ, here it is. But if we click on this view the output path diagram, जब से हम क्लिक करेंगे तो आपका ये वैल्यू शो करेगा, right? Here two options are unstandardized values शो करेगा. These are the unstandardized values, and if we click, it will call standardized values. So इसमें आपको जानना पड़ेगा what are the various values represents for, because it is too much conceptual. I'll let you know unstandardized values and standardized values. Remember, unstandardized values is what is basically called the regression values, and standardized values means what is basically जैसे R square की हम बात करते हैं and standardized beta की बात करते हैं इसके बारे में, right? So I'll discuss it in my PowerPoint so that it will be easily understandable. Unstandardized estimates. Now you can see MQ से कुछ values है. MQ1 observed variable and MQ is a latent variable, right? So unstandardized, the mean and variance appears at the top of the independent variable. Intercepts A appear in the at the top of the dependent variable, right? And say intercepts and intercepts A appears in the top of the dependent variable, right? This is our intercepts. जो हम बात करी थी regression coefficient x equals to I can remember t plus e, right? जो हमने पहले बात करी थी, तो वो जो है this is जैसे हमने regression equation की हम बात करते हैं y equals to a plus b1 into x1 plus b2 into x2 and so on. So these are the a value, right? Or the mean and standard deviation appears in the top of the dependent variable. ये इसका mean and standard deviation. Mean is assumed to be 0 here because of normality, क्योंकि ये normally distributed होना पड़ेगा आपके latent variable को, and it is 0.72 is the variance here, right? Unstandardized regression coefficients B, जो हम कहते हैं bxy and by regression coefficients appears at the top of the arrow. So these are the regression coefficients. See, जिसमें मैंने 1 डाला था, this is 1, where I have put 1 as a regression coefficient. So it is 1 here, और बाकी जो है, this is the reference point. Remember, हमने डिस्कस करा था पॉइंट में कि दिस इज आवर रेफरेंस पॉइंट इज टू बी अज्यूम टू बी 1 हियर एंड देन अकॉर्डिंगली इट विल चेंज 0.86 1 पॉइंट, दैट इज यदि ये 1% है तो ये 1.16 एंड ये उससे ज्यादा 1.21. So this is our reference point. 1 is to be assumed here as a regression coefficient, right? So इसके लिए हमें कोई स्टैंडर्ड एरर क्रिटिकल रीजन की क्रिटिकल वैल्यू की जरूरत नहीं है. नाउ these are the intercept and b value which are to be in our unstandardized estimate model, right? जहाँ पे हम क्या करते हैं, SE are the standard error and C are the T value. ये तो हमने पहले ही बताया है कि ये स्टैंडर्ड एरर है, ये आपका T वैल्यू है और ये आपका वो है क्या कहते हैं सिग्निफिकेंट वैल्यू स्टार स्टार स्टार. That means 0.000. यदि ये 0.000 नहीं होगा then it will be 0. कुछ भी वैल्यू होगा that will be shown here. Otherwise in in AMOS, if it is 0.000, that is 99.99% significant, then it will show you star 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 triple star. Right? Standardized में आपके पास option है this R square appears at the top of the dependent. This is the R square, that is individual contribution. हम बात करें, right? And ये जो these are which call the beta, that is standardized beta. This is called standardized beta. Remember what is the difference between the beta and standardized beta? Basically ये जो beta होता है, this is the beta is called R for one independent that is R. If there is a one dependent variable, then one independent variable, then beta is the same as R. मतलब यदि आपके पास ये चारों नहीं रहेगा, just MQ depends upon MQ4 depends upon MQ, या MQ4 depends upon MQ, then एक ही equation है, that is single regression equation, normal regression equation, not multiple regression equation, right? So यदि single normal regression equation होता है तो R value और beta value same होता है, right? But this is R square, so it is R means R square means contribution, it is showing here, and the beta values are showing here, right? This is the concept of interpretation of B, beta and R square. B, this is unstandardized coefficient, हमें B मिला था. The amount by this concept, the amount by which dependent variable changes if we change the independent variable by 1, remember, by 1. If we change 1 unit of independent variable, then how the dependent variable will change? This is our beta, B. If we are talking, stands for unstandardized coefficient. If we are talking about beta, that is standardized coefficient, it is the impact of variation of dependent variable. If there is 1 unit variation, remember this is amount independent variable, right? The impact of variation in dependent variable, if there is 1 unit of variation in the independent variable. एक unit variation यदि मैं कर देता हूँ, जैसे if it is 99, I have, if it is 65, मैं इसे घटा के 64 कर दिया. So what I have done, I have one change, I have varied it by 1 unit. एक unit variable, one variation हमने कर दिया. So कितना unit variation होगा? Now again is R square. What is mean by this term R? It represents the proportion of variance of a dependent variable that explained by independent variable or the variables in regression model. That is, it represents the proportion the independent variable that explained by an independent variable or variables. Means यदि मैं बात करता हूँ कितना proportion explain कर पाता है MQ1 0.66. This much portion is being measured by this term MQ1. So what I say is represent the proportion. कितना proportion मतलब इतना proportion के बाद बाकी proportion, the remaining proportion is measured by whom? Measured by some other variable in error term which are discussed variables. In only this portion, and the rest of the portion is being measured or hampered the other variable that is measured or variation explained by some other variable which has not been introduced in our model, right? The variables which are not introduced in our model is being put into the error term, right? So in this way आपको क्या करना है, all the variables, all the what we say that is called measurement model के बारे में आपको same मिलेगा. हमने इसके बारे में बताया, that is MQ only. In the same way you can go for MQ के साथ other जो variable other जो model है, measurement model है, सारे measurement model पे आपको इस तरह का correlations and dependence निकलेगा, right? Now ये है second order. Now I have talked about the second order. Now ultimately हमारा वो था हम TP, that performance depends upon CQ or not. Of course sometime it will depends or sometime it is depends upon sorry, it is depends upon CQ. Now the question is how it's the impact. Here it is again, standardized and unstandardized, standardized estimates and unstandardized. So you can see the beta value, B value is theirs, beta R square that is 42.6% is being explained. CQ जो है इसका TP के साथ जो relation है, CQ is being explained 42% of this TP, and the rest of the TP is being explained by other factor which is not being included or which is. This is our concept, this is our relationship, जो serial relationships है, इस तरह से हम discuss करेंगे. Reporting of CFA, तो इसे हम काम करेंगे. So हमें कैसे report करना है, that is what is the gist, how to report. एक structure equation model को आपको report करना है तो आपको इस मॉडल इस फिगर को ध्यान देना है. Actually this figure is not mine, मैंने कहीं से लिया है. So I cannot remember. So reporting करने के लिए you have to go for validity issues is discussed and model fit is to be discussed. Regression, यदि आपका regression coefficient 0.05 से कम है, then it is said that this particular variable is depends upon this statistically significantly impact is there. Validity measure करोगे तो validity के लिए you have content validity and construct validity. In content validity you have to go for the expert opinion, and in construct validity you can go for the convergent and discriminant. यदि convergent validity है तो ये आपके पास options है. CR must be, these are the minimum 3 जो पहले मैंने बताया था. बहुत सारे all various all the values are there कि और बहुत सारे वो दिखाए आपको इंडेक्स दिखाए जिसको हम कहते हैं कन्वर्जेंट वैलिडिटी होने के लिए ये होनी चाहिए, दिस इज टू बी देयर और लाइक दैट, बट इट इज द मिनिमम रिक्वायरमेंट, दैट इज CR मस्ट बी ग्रेटर देन 0.7, AVE मस्ट बी ग्रेटर देन 0.5 एंड CR मस्ट बी ग्रेटर देन AVE. और डिस्क्रिमिनेंट वैलिडिटी के लिए यू हैव टू गो फॉर दिस टू मिनिमम, दैट इज ABE मस्ट बी MSV ग्रेटर देन एंड AVE मस्ट बी ग्रेटर देन ASV. मॉडल फिट है या नहीं, वेदर योर to be model is fit or not is to be report करना पड़ेगा. That is we write the analytical part of your study. You have to report all these things. You have to report the chi-square statistics. You have to go for the goodness of fit, you have to go for the badness of fit. के बारे में मैंने डिस्कस नहीं करी, कोई बात नहीं. गुडनेस ऑफ फिट समटाइम क्या करता है ना, तो गुडनेस ऑफ फिट मीन्स कितना अच्छा है, और बैडनेस ऑफ फिट मतलब कितना कम बुरा है. सो डोंट दैट इज, इसमें आप इतना डिटेल में ना जाके सीधे सीधे हम बात करेंगे. देयर इज एन कॉन्सेप्ट ऑफ CFI, GFI, IFI, इस तरह का AGF, AGFI, ये जो कॉन्सेप्ट्स है, दीज आर द measures of goodness of fit, and it is RMSCA and RMR. These are the two index which will show you whether your confirmatory factor analysis is good or not, right? So you have all these things when you are reporting your analysis. रूल्स के बारे में मैंने बता ही दिया. फॉर एग्जांपल, यदि मैं बात करता हूं कि सेकेंड ऑर्डर कंस्ट्रक्ट शुड बी यूज्ड व्हेन देयर एग्जिस्ट एन हाई कोरिलेशन अमंग द डिटरमिनेंट्स. अभी रिसेंटली बताया कि आपके ये जो सेकेंड ऑर्डर कंस्ट्रक्ट तभी बन सकता है जब इन दोनों के और मे बी इनके सारे के कोरिलेशंस हाई हो. यदि एक का कोई कोरिलेशंस हाई नहीं है, उनको अलग करोगे. दिस विल बी सेपरेटेड from joining. That means to say, when we join the variables 1, 2, 3, 4 together into another variable, all the joined variable must be interlinked, is to be highly correlated. This is what about highly correlated. The purpose of the second order is to reduce the multicollinearity among the determinants. Remember, क्यों हम करते हैं कि multicollinearity यदि determinants के अंदर रहता है, उसको कम करने के लिए हम इसको इस्तेमाल करता है. Right? Now, this model fit can be improved through modification index. I showed you already कि model fit को मॉडल को और ज्यादा अच्छा फिट करने के लिए आपको क्या करना होता है, modification index. You have to remove the modify terms, right? Convergent validity can be improved by outliers. मोहलनबीस डिस्टेंस में जो हमने 12-15 वेरिएबल डेटा को हमने रिमूव करा था मोहलनबीस इंडेक्स दे के, वो क्यों करते हैं? क्योंकि हमें कन्वर्जन वैलिडिटी को, यदि हमारा कन्वर्जन वैलिडिटी सही नहीं है तो यू शुड हैव टू चेक योर मोहलनबीस इंडेक्स to delete some data you have obtained, so that your data should be valid, convergently valid. For today, I think I have some more things are there, moderation and mitigations and etc. I think it will take some time. I'll stop it here now. That's all for today. Thank you.
Thank you very much. Thank you very much. Thank you, Dr. Soumen. It was very good. I know that it is very technical, and because of being technical issues, and that too, I got few messages from some of the participants that it should be 1 week program, something on only on these softwares, so that we can apply some hands on to that practically also. You teach, and then we can have practical sessions parallel and simultaneously, and we can practice it together, because otherwise it is such technical issues that if we don't practice it together, it becomes a bit tough. But still, your presentation was excellent, and I hope that the participants will try, and because the lecture is recorded, it will be available on YouTube. It will be beneficial for them. They'll try and try to work it on. I'll see if there are 1 or 2 close questions we can take, and then we'll can you tell us what is degree of freedom? Somebody asked.
It is a layman view. In layman view, you can say, if number of observation, for example, basically you can say like that, if your number of observation is 5, then your degree of freedom will be 4. That is, degree of freedom is n-1. That is what we say is basically why it is used. If we have time, I can explain maybe within 1 or 2 minutes. Let me tell you when we are talking about a parameter and a statistics, right? For example, यदि हम बात करते हैं बहुत easy standard deviation, है ना? Standard error sigma by √n. This is the concept sigma by, right? Because when we are calculating the standard error or maybe standard deviation, then what we do it divided by n. क्यों करते हैं? Because n stands for the number of observation and we are calculating it from the sample, right? जब हम इसी सैंपल से काम करते हैं, दैट इज सबसे होल एज ए होल काम करते हैं, तो हम मतलब एज ए होल काम करते हैं तो हम डिवाइडेड बाय n करते हैं। एज ए होल नहीं करते तो उसमें आपके क्या होता है, इट इज लाइक एक कंसेप्ट होता है कि हर स्टैटिस्टिक्स का कुछ कैरेक्टरिस्टिक्स होता है, राइट? 4 कैरेक्टरिस्टिक्स है जिसको हम कहेंगे द इम्पोर्टेंट कैरेक्टरिस्टिक्स, लाइक कंसिस्टेंसी, रिलायबिलिटी और that is another 4 or another 2 are there, reliability, consistency. यदि आपके values यदि variable आपके parameters, आपके statistics यदि consistent बनाना है, that is reliable बनाना है, so what we have to do, you have to multiply but divide not by n but by n minus 1. So this n minus 1 concept comes from this. So it is to make your statistics I mean to say is any calculation which you calculate from this from the analysis is called statistics. So in that case हम क्या करते हैं कि हमारा जो n है, डिग्री ऑफ फ्रीडम, जहाँ पे भी हम n इस्तेमाल करते हैं उसको बदल के n-1 इस्तेमाल करते हैं, so that we can make our जो statistics, make our statistics significant or maybe make our statistic reliable, right? So this is the concept of.
Okay, sir.
Hello.
Yeah. We'll take one last question, sir. Hello.
Yeah.
Yeah. Am I audible, sir? Am I audible?
Ha, you are audible.
Okay. It is clear, sir. Thank you. And last question, sir. What is the meaning of quest?
I think it is so because the concept is of HR, right?
Yeah.
So quest है ना, ये सबसे अच्छा आंसर दे पाएगा संजीव महाजन, because of he is HR background, right? So, what is cultural quest?
The quest is the learning capacity, how best we are able to adjust with the cultural issues. That was a factor which we have taken up as far as HR is concerned. Okay, sir. Thank you very much. It was a very nice session. It was excellent learning, and we because of the time issues will not be able to take some other questions. And I hope that in future also we'll arrange something specifically on quantitative analysis, quantitative data analysis, and then probably we can have something more on SPSS, R, AMOS, so that all the participants can be benefited.
Yeah. Thank you, sir.
Thank you very much. It was great to have you.
Thank you to all. Yeah.
Thank you.